3 million Americans can't use regular condoms. A latex allergy puts them at risk with every encounter. The solution? A nitrile rubber device that must withstand nearly 5 gallons of air without bursting, stretch 700% without tearing, and pass electrical conductivity tests that detect holes smaller than a human hair. It's the only physical barrier method controlled entirely by women. And you're about to see how it's made. If you want to understand how the industry ensures your safety, stay until the end of the video. Don't forget to subscribe to the channel, leave a like, and comment below. White latex drips slowly from rubber trees in tropical plantations at dawn. In the United States, the female condom market generates over $150 million annually, with steady growth since FDA approval in 1993. Stainless steel tanks receive filtered latex for refrigerated transport to the factory. Temperature must remain below 77 degrees Fahrenheit throughout the journey. Otherwise, the material coagulates and permanently loses its elastic properties. Chemical reactors synthesize nitrile rubber as an alternative for people allergic to natural latex. In the United States, approximately 3 million people suffer from latex allergies, making nitrile female condoms essential for this specific population. White latex flows through a metal sieve, while bark fragments and plant fibers remain trapped on the surface. International standards for medical devices require at least 3 filtration stages. Stainless steel tanks store latex under controlled temperature and humidity, while a technician monitors digital parameters. Compound maturation for up to 72 hours develops ideal elastic properties, increasing the female condom's final strength by up to 30%. Industrial mixers homogenize polymers with vulcanization accelerators at high speed. The formulation must contain at least 12 different ingredients to guarantee elasticity, strength, and durability throughout the product's 5-year shelf life. Successive layers of pink polymer are deposited on molds through repeated dipping cycles. Each layer adds approximately 0.8 thousandths of an inch in thickness, totaling between 1.6 and 2.8 thousandths after 3 complete immersions. Technicians monitor digital panels while stainless steel reactors process polymer compounds for female condoms. Each batch's precise formulation requires control of over 20 simultaneous variables, including temperature, pressure, and agitation speed. Vacuum chambers eliminate microscopic air bubbles from the polymer emulsion before production. A single air bubble can create a weak point in the condom, compromising its contraceptive effectiveness, which exceeds 95% when used correctly. Maturation tanks allow chemical stabilization of the compound for periods up to 72 hours. This crucial step develops the final elastic properties of the material, determining the quality of the female condom produced. Micrometric filters remove impurities from latex, ensuring exceptional purity for medical manufacturing. Particles larger than 5 micrometers are eliminated in this process, ensuring base material homogeneity for female condoms. A red-cured polymer sample undergoes compression testing in precision laboratory equipment. The material must recover its original shape in less than 3 seconds after 50% deformation to pass approval. Dynamometers measure the force required to break the stretched female condom material. The elastomer must elongate at least 700% of its original length before rupture, ensuring resistance during normal use. Anatomical ceramic mandrels are heated to precise temperatures before immersion in the polymer. The female condom's unique shape was developed after more than a decade of research, being the only barrier contraceptive method controlled by women. Pink polymer jets flow from sanitary pipes into a production tank in a controlled industrial environment. Each transferred batch contains enough material to manufacture approximately 20,000 female condoms in a single batch. An automated line simultaneously dips dozens of mandrels into a pink emulsion tank, while already coated units await drying. A single modern production line processes over 50,000 female condoms per 8-hour shift. Automated systems apply medical-grade silicone lubricant inside and outside each unit. The precise quantity of approximately 1/6 of a fluid ounce reduces friction by over 90%, significantly increasing comfort during use. A mixer disperses medical-grade silicone lubricant in a tank under blue lighting, creating a creamy texture. Each female condom receives exactly 1/6 of a fluid ounce of lubricant, reducing friction by over 90% during use. Laser sensors measure polymer film thickness in real time during deposition on mandrels. Variations exceeding 5 micrometers trigger automatic process adjustments, maintaining uniformity throughout daily production. Flexible inner rings of polyurethane are injection molded in automated machines. This revolutionary component allows the female condom to be inserted up to 8 hours before intercourse, offering unparalleled convenience compared to male methods. Industrial washing removes chemical residues from the manufacturing process of each female condom. Multiple rinse cycles with purified water reduce residual compounds to levels undetectable by the most sensitive analytical methods available. White female condoms advance on a metal conveyor through an industrial final drying oven. Filtered air at 104 degrees Fahrenheit removes residual moisture in less than 15 minutes, preparing units for the critical quality control phase. Electrical conductivity tests identify pinholes invisible to the naked eye in each unit produced. In the United States, federal regulations require 100% of condoms to pass this test before release to the consumer market. Pneumatic equipment inflates female condom samples until the point of rupture. The product must withstand at least 4.8 gallons of air before bursting, equivalent to over 40 times its original volume when properly manufactured. A spherical probe presses a pink female condom sample while the monitor records the force curve in real time. The material must withstand at least 9 pounds force of point pressure before perforation, simulating extreme mechanical stress conditions during use. An automated line packages female condom sachets, while monitors display production statistics and rejection rates. Traceability systems record each unit produced, allowing identification of any product's origin in seconds. Ovens simulate years of storage in weeks to test female condom stability. Accelerated aging tests at 158 degrees Fahrenheit for 7 days. Equal approximately 4 years of storage under normal conditions. A laboratory technician pipettes female condom material extracts into cell culture plates for biocompatibility analysis. Cytotoxicity tests verify the absence of substances that could cause irritation to sensitive human body tissues. Test patches applied on human skin evaluate the sensitization potential of female condom material. The absence of redness or irritation after 48 hours confirms dermatological safety for use in prolonged intimate contact. Computers automatically record all quality parameters for complete batch traceability. Manufacturing data is stored for at least 10 years after the expiration date, as required by medical device regulations. Quality managers authorize release of approved batches through certified digital signature. Legal responsibility for product safety falls upon the professional who authorizes each release to the consumer market. Volumetric dispensers apply the exact amount of lubricant to each approved female condom. System precision ensures variation of less than 1/100th of a fluid ounce between units, ensuring consistent consumer experience. Hermetic sealing machines operate at temperatures exceeding 302 degrees Fahrenheit. Sealing bar contact time is calibrated in milliseconds to ensure perfect fusion without damaging the internal product. Printers apply unique barcodes allowing individual tracking of each package sold. Advanced serialization systems allow identifying the exact origin of any unit in question of seconds. Display indicates leakage detection and failure in a female condom sachet during package integrity testing. Differential pressure sensors identify microscopic perforations in the laminated aluminum, automatically rejecting compromised units. Aluminum sachets containing female condoms accumulate in ordered stacks, while cardboard boxes await in the automatic feeder. A single cartoning line processes over 3,000 units per hour, meeting demand from markets in over 140 countries. Cartoning machines assemble retail boxes at high speed, with sachets and instructions included. In the United States, each box typically contains 3 units, while free distribution programs often offer packages with 12 condoms. Pharmacies display female condoms in the intimate health section for discreet consumer access. Research indicates that over 60% of purchases in the United States are made by women, reversing the historical male purchasing pattern.